Okay, so let's discuss set relation function chapter. So it's a important and easy chapter. Important why? Because it's easy and its question are also asked. So why leaving this? First of all, let's discuss about object. So everything in this universe, whether living or non-living, is called an object in our mathematical language. Everything. Any collection of well-defined objects, okay, well-defined objects is called a set. By well-defined objects means that well-defined objects we mean that a given a set and an object, it must be possible to decide whether or not the object belongs to the given or the particular set or not. The objects in set are also called its members or elements. Okay, let me repeat. Any collection, there is a collection of well-defined objects is called a set. Collection of objects which are well-defined is called a set. Well-defined means that we have to specify whether the object belong to a particular set or not. It has to be very clear to us. So we mean that given a set and an object, it must be possible to decide whether or not the object belongs to the set. The objects in the set are also called its members or elements. Sets are denoted by capital letters. Sets are denoted by capital letters, while the elements are denoted in general by small letters. This is general thing, not a rule. So a set can be this. A set can be a collection of all prime numbers less than 100 because there are certain objects and these are very well defined. This set is very particular in nature. There's no doubt whether any object of it will belong to it or not. No, it is very certain to us. And talking about some example of not set, this cannot be a set. This is also a collection of objects, but the here as we read it, the collection of all interesting books. So interesting is very subjective to nature. Some book may interest you, some book may not interest the other person. So interesting is very subjective term, and that's why the object, the particular book, whether it will belong to this particular set or not, it's a ambiguity. It's ambiguous in nature. That's why we cannot term this particular collection as a set. Okay. See the second example. Tanish, till now we have discussed about what is object. Everything in the universe, whether living or non-living, is called an object. Talking about sets, any collection of well-defined object is called a set. So like any collection of objects is called a set, given that those objects, we have to be very particular about the nature of objects being belonging to that particular set. Okay, so well-defined, we mean that a given a set and an object, it must be very, possible to decide whether or not the object belongs to the set. If we are very sure that if we are sure about the nature of object, whether it will belong to set or not, then we can say, then we can term that particular collection as a set. So here we can read the examples. Example number 2, the collection of all natural numbers. So whichever natural numbers we are going to write in a set. So it is very sure about every object, every number that it will belong to this particular collection. And that's why this particular collection is known as set. Reading third example, the collection of all countries in Asia. All countries are Asia are well defined. They are specified. So this is also a defined collection of objects. That's why this is also in set. The collection of all planets in our solar system. They are also well defined. Now some examples of non-sets. The collection of the most beautiful songs. So it is also subjective. The collection of the happiest people in a city. It is also subjective. The collection of all thoughts in a person's mind. They cannot be well defined. So these are some examples of non-sets and sets. Are they clear, everyone?
Yes, sir.
Yes. So now let's discuss about this symbol. So as we discussed that the capital letter is usually used for sets, and the small letter is used for object or element or member of a set. So now this particular statement or this implies that a element A is an element of set A. Okay. This says that A is not an element of set A. Okay, this is the meaning of this particular sign. We can also write it as, okay, but it's not generally written like this. So prefer writing in this format. Understood?
Yes, sir.
So let's take an example. Let's read this first, and then here we will take some example. There are some standard notation for say, some special points, and you have to like kind of learn them. Well, just understand them, and there's no need to particularly cram them because it's very self-explanatory in nature. Yeah, okay. So it's basic fundamentals. The set of all natural numbers, that is a set of all positive integers, is denoted by n. So does 2 belongs to n? Is this true or false? Tell me. So the set of all natural numbers, uh, all positive integers, natural numbers are positive integers, is generated by n. So now the question is, I'm asking whether 2 belongs to n. This is what belongs to, or 2 is an element of n. N is what? N is a set of all natural numbers. Okay, so n is like n will be written in this format. So all natural numbers are there 1, 2, 3, 4, 5, 6. Okay, so this is the set n. Now we have to tell whether 2 belongs to n or not. True or false? Come on, unmute yourself and answer.
The
True.
first one is true, sir.
Yes. Now Tanish will tell. Yes, Tanish, what was the second?
Second one is false, sir.
Okay, good. What about third?
Third one is also false.
Yes. Now let's discuss about the next set. The set of all integers is denoted by z or I. What is there to remember in these these letters that n represents the set of all natural numbers, z or I represents the set of all integers, or q represents the set of all rational numbers, and q complement represents all the set of all irrational numbers, and the set of all real numbers is denoted by r. Set of all positive real numbers is denoted by r positive. And what is r positive? starting from starting from 0 to infinity. Okay, positive infinity. Set of all complex numbers is denoted by c. Set of all positive rational numbers is denoted by q positive. Clear? Any doubt?
No, sir, no doubts.
Any doubt what is integer, rational number, real number, complex number, positive rational number? Any doubt? No doubt.
So, what is complex numbers?
What is complex numbers? So earlier we also have discussed this in the basics of mathematics class. Complex numbers are made by are represented by z. and are made of two parts. One is real part of complex number. Other one is imaginary part of complex number. This real part is just like real numbers. So there's nothing new about it. There is an imaginary part which has a unity of iota. Okay, iota is what? Square root of -1. And basically, it will be written like in this format: x plus iota y, where x and y are real numbers. Iota is the unity of imaginary number, and that's how this becomes a complex number. So we'll discuss about it later in the chapter complex number. Understood? Do you have a rough idea that what is complex number?
Yes, sir.
Yeah. So any doubt? Clear everything?
Clear, sir.
Yeah. Please read all these by yourself and tell me. Done?
Yes, sir.
Danish done? Please keep on responding. So now let's discuss about the representation of set. So listing method in this simply will set is represented by writing its element in a bracket, curly brackets, and separated by comma. Every element will be separated by comma. So this is a set of vowels of English alphabet and A, E, I, O, U written in curly brackets. So this is a listing method in which we now, so this is about listing method. This is also known as tabular method or roster method. So in this simply direct elements are written. When we talk about set builder form method, so what is given to us is that a definition will be given to us, and from that definition we can make out and we can think for the elements of that particular set. We can find out the elements from the definition. Let's read the definition. In this method, instead of listing all elements of a set, we write the set by some special property, a property satisfied by all elements. And write it as A is equals to X ratio PX. Let's see an example, you will be able to understand. Where PX is a property which is satisfied by X. Let's look for an example. So this particular form is set builder form. Where X is belonging X. So like we do not have to modify the X. Basically, X is a function of X only, like f of X is x only here. So p of x, let's write it as p of x is x only. That's why they have written x that belongs to natural number, and x must be less than 5. So this is the definition of set. It should be a natural number less than 5. What is left? Only 1, 2, 3, 4, 5. So this method is also known as rule method or property method. Any doubts?
No, sir.
Clear? In writing the elements of any set, there is no consideration of sequence. Example, A, E, I, O, U and E, I, O, U, A are two same sets. They're same set because their elements are same. And there's no consideration of sequence. You can write it anyhow. Let's discuss about the types of set. Empty set. Empty set is basically a set lacking elements. So a set consisting of no element is called an empty set or null set or void set. All these three words are important. Is denoted by this phi or curly brackets having blank, having nothing in between. So empty set is denoted by this or this. Okay. So let's take an example. X belonging to natural number and should be lying between 3 and 4. So there is no natural number lying between 3 and 4. So that's why the set is having no elements and represented by this. If we had to represent this in the element form, like in what was that? Listing method, tabular method. So we had to write it this only. There is no element in between these curly brackets. Set which is not empty is called a non-empty set or non-void set. Okay. And now let's discuss about singleton set, a set consisting of only one element. Now, understand there's a like how many elements are there in the set? A set is represented in like this in this method. So if there are nothing written in between, this is an empty set. If there is something, even one term written in between, so this set is having one element. That's why it will be called as singleton set. Now let's look for a special example that there is an element of 5 in here. This is element 5. So now this particular set, this set have one element between the curly brackets. That's why it's a non-empty set and it will be termed as singleton set. Because it is having one element, that is 5. Okay, this and this is very different. Please take note of this. This is a representation of empty set, and whether this is singleton set. The set having zero element, like having an element as 0 is not an empty set, as it contains one element, that is 0. Same goes for the set. The set curly brackets having element 5 is not an empty set, as it contains one element, that is 5, which was 0 earlier. Okay, this is a point to note, and like no confusion need to be created from it. That's why I'm telling that much on this. Clear about singleton set, why this particular set is considered as non-empty set and singleton set. Any doubts?
No,
Should
sir.
I?
No, sir.
No doubt. What about Tanish?
No doubt.
So let's discuss about finite set. A set having finite number of elements is called finite set. And infinite set, a set having infinite number of elements is known as infinite set, like set of points lying in a plane in an infinite set. And also like set of natural numbers is also an finite set. Cardinal number of a finite set. So a finite set will be having some finite number of elements, and that particular finite number of elements is cardinal number of that finite set. This is denoted by n of a, generally n of a only. The number of elements of finite set is called its cardinal number, and it is denoted by n of a. For example, set means set of vowels. What is the cardinal number of the set? Please tell.
5.
Good. And what is the cardinal number of this set? Please tell, don't be confused.
No, null is there, so that's why I'm thinking, sir.
Hmm?
Is it 0 or null? I don't know, sir.
Try, no problem. Yes, Tanish.
Maybe 4.
What are the number of elements in this particular set?
5, sir.
Yes, there are 5. These are also element. Okay? This is also data. These are also respected. Okay. So the set, like, so this is the cardinality of the set. This is also the cardinality of the set. If two sets number of elements are equal, then A and B are called as equivalent sets. Two finite sets A and B are said to be equivalent if they have same cardinal number. The sets A and B are equivalent if n is equals to nb. Clear? Clear?
Yes, sir.
Clear equivalent set. Yes, let's now discuss about subset and superset. Okay, first, take an example, like let's say there's a set of this is a set of all alphabets, English alphabets. Okay, so this is A B C D F G H I J K L M N O P P Q R S T U V W X Y Z. So what is the cardinality of the set?
26.
Yes, 26. Now please tell, let's say B is the set of vowels. And C is the set of consonants in English alphabets. So, blah, blah, blah. Okay. So these are like set of vowels and set of consonants. So if we understand, does B, this set, the all elements of set B belongs to set A or not? True or false?
True, sir.
Very good. Does all elements of C belongs to A or not?
True, sir.
Yes. So now in this case, otherwise we were saying if there was a particular element here, we were saying that this particular element, sorry, this particular element is an element of the set A. Now, as here, this is not an element here, this is a set itself. So we will call it, this is B is subset of A. And here we will call C as subset of A. Okay. And in this case, as C is the subset of A will be known as superset, like the father of C. And similarly, A is superset of V. Is that clear? What is subset? What is superset?
Yes, sir.
The set B is said to be a subset of set A if every element of set B, note this point, every element of set B is also an element of set A. Symbolically, we can write it as B contains C. So here, like this is a different sign used here, used for sets. Okay, and it can also be a case that set B and set A are equal. That's why the equality thing is also considered here, and it may be represented in both directions. And it is also the case when B is the subset of set A, then A is superset, like A is a father, A is superset of B. So this, please read this and read this. Wherever the mouth of wherever the mouth of the C is open towards, that will be the superset. Got it?
Yes, sir.
So for sets, or like we have taken this particular symbol used for elements, because these are elements here. Now for set, we are going to use this symbol. This symbol contains this symbol. Okay, so let's replace. So evidently, if A and B are two sets such that X belongs to B, X element is belonging to set B and X belonging to set A, then B is a subset of A. The symbol stands for, implies, we read it as X belongs to B, implies that X belongs to A. So this is something you'll understand by using example. So here, let's say that if like E is belonging to B, true or false? Do E belongs to
Yes.
set B?
Yes, sir.
Yes. Yes, it is the case. So as we know, B is the subset of set A, है ना? So it is for sure that from using these two conditions, that A is belonging to B and B is a subset of A. So it is for sure that E will also be belonging to set A. Is this true or not? Do E belongs to set A or no?
Yes, sir. True.
Yeah. So this is the this is the thing. This is the property about subset. This is what is written here. Let A 1, 2, 3, 4 and B 1, 2, 4. Here B is a subset of A. And if 2 belongs to B, then it is for sure that, and it is also given that B is a subset of A. So it is for sure that 2 will also be belonging to A. Clear? Clear about subset and superset?
Yes, sir.
Yes. I want you all to read this much once again. Please read. Done.
Yes, sir.
Done reading or slept?
Yes, sir.
Yes. Now let's discuss about proper subset. The set B is said to be a proper subset of set A if every element of set B is an element of set A, whereas every element of set A is not an element of B. It's basically that the condition of inequality is not considered. Earlier, if B were to be only a subset, here B is a subset of A, but for B to be proper subset of A, it has to be that B is the subset of A and A should be bigger than B. That's when this will be a proper subset. Clear? Earlier, it was the case that even B and A sets could be equal, but now they cannot be equal as we are defining B as a proper subset. Any doubt? We write it as B is contained by A and read it as B is a proper subset of A. Thus, B is a proper subset of A if every element of B is an element of A and there is at least one element in A which is not in B. So, like A has to be bigger. Observe that A is contained by A, and that is every set is a subset of itself, but not a proper subset. So it's a important point to consider. Every set is a subset of itself, but not a proper subset. Now A cannot be here. A cannot be written as A is not a proper subset of A itself. Why not? Because A like the second set has to be bigger so that the subset can be termed as a proper subset, but it is not the case. That's why. Clear? Any doubt? Any doubt? Please respond.
No doubt, sir.
Okay. Null set is a subset of every set and each set is subset of itself. Null set is what? Empty set. It is a subset of every set because it is like emptiness. So it's just a point to remember. You'll come to know and understand it later on when you'll use it multiple times and think deeply about it. So null set is a subset of every set, and each set is also a subset of itself. Number of subset of a finite set of n elements is 2 raised to power n. Important. Let me so let's consider there is a set. Okay. How many elements are there? How many elements are there? Don't sleep. Please respond. How many elements are there in the set A? Yes, Tanish.
3 elements.
Yes, yeah, reading. 3. Good. So there are 3. So 2 raised to power 3 is what? There should be 8 subsets. Let's try to make it subsets. So listing all the subsets, and the whole set of all subsets is also known as power set. The set of all the subsets of a given set is said to be the power set. So let's write it here. So this is the power set of A because it will have all the subsets of this. So as we know, the empty or null set is a subset of every set. So there's a 1 5, and this 0 itself is a subset of itself, and 1 and 2, and am I writing it correctly? No, I'm not. So 5 is a set, that is why we have represented that in particular manner, but 0 is an element. 1 is an element in this particular set, and this is also a subset. So these are all subsets. That's why they are written in curly brackets. Otherwise, 5 can be written as like this also. So every set is written in curly brackets. These are subsets. And 0 1 is also a subset of this A. And do you agree 0 1 is the subset of set A? Do 0 1, like this particular set, think of this set, whether it is contained in set A or not, true or false. Come on, try. Answer. Okay. So should I repeat or something? What is the doubt? Tanish, Yarini.
So could you repeat the question, sir?
Okay. So I'm saying that whether this set uh, does it belongs to set number A, is it a subset of set A or not? True or false? This is the
True,
question. Yes?
true, sir.
No. Okay. No, it is true. Why? Because 0 1 is a subset of A set. Why? Because 0 as an element is also present there, and 1 is also present in the set A. That's why the case is. That's why it is a subset of set A. Understood?
Yes, sir.
Yes. So similarly, 1 2 is also a subset, and also 0 2 is also a subset. And all 3 elements is a set. Like the whole set A is also a subset of A. So let's now count how many sets we have. 1 2 3 4 5 6 7
Eight.
8. Yes, there are 8 number of elements in. There are 8 number of subsets in, and there are 8 number of elements in power set. 2 raised to power n of A, cardinality of set A. Clear? Any doubt?
No, sir, no doubts.
The set of all subsets of a particular set is known as power set. So these two are very important. Please consider them. And this is also important. Equal sets. two sets A and B are said to be equal if each element of A is an element of B and each element of B is an element of A. Simple. So there's nothing much, like they are just they can be just misarranged, but they will be considered as an equal set. Same set. Okay, clear?
Yes, sir.
Whenever we have to show that two sets A and B are equal, that is that we have to show that A is a subset of B and B is also the subset of A. So let's now discuss about universal set. In any discussion in set theory, we need a set such that all sets under consideration in that discussion are its subsets. Such a set is called the universal set and is denoted by U. If we are discussing about numbers, so what is the universal set about numbers? If we are, let's say, if we are only discussing about real numbers, different kind of real numbers, natural number and rational numbers, integers, or sorry, rational numbers, integers, whole numbers. So there, these all can be, these all particular sets, these all individual sets are subset of real number. So we can consider real number as a universal set here in this particular discussion. And even okay, so let's consider it for something else also, make you better understand. If we are discussing about vowels, if we are discussing about consonants, if we are discussing about alphabets, you know, so like the alphabets can be the universal set because these two are the subset of this particular set. So this, in this particular discussion, alphabet can be your universal set. Or clear? Any doubt?
No doubt, sir.
Okay. So and you will come to know about universal set more when you will practice questions. So power set we have already discussed, the set of all subsets of a given set. A is said to be the power set of A and is denoted by P of A. And like there is a set 1, 2, 3. Its subsets are, one is empty set, and that another one is the set having element 1 only, because this is also a subset of this particular set A, 2, 3, 1, 2, 2, 3, 3, 1. These are all sets. Okay, these are all sets because they are written in curly brackets. 5 can also be written as curly brackets with no elements. So these are all sets which are here subsets to set A. The elements of power set are called the subsets of A. The power set of each given set is always non-empty. The power set of each given set, the power set of is always non-empty, means that it is always the case that, like, let's say if there is a non-empty set and we have to write the subset of this non-empty set, what we'll do, so there will be phi which will be definitely subset of this, because phi and the set itself are always a subset of itself, are always a subset to the given set itself. Phi and the given set itself. So which these are these are the same. So there's a mistake which I'm doing. These two. No. Because phi is not an element here. Phi is not an element here in this particular set. So that's why we cannot take it as this. So there is only one subset of this. There is phi only, and because there's an empty set, of course, every time in the power set, because empty set is always the subset of any given set according to our property, and the set itself is also an also a subset. So phi is also written here. So no use of writing it twice. So that's why this will be having only one element. And if we go by the formula 2 raised to power n by a, its set of its number of element is 0, right? So this is also 1. That's why there is only one element in the power set. So the power set of each given set is always non-empty because there will be at least one element in the power set. Clear? Any doubt? Any doubt? This is complex. You can ask me again. I will explain it again. Any doubt?
No doubt, sir.
Okay, good. If A is a finite set of n elements, then number of elements in power set will be 2 raised to power n. Simple. Okay. Please understand this concept very clearly about empty set. This is important. Okay. And understand the difference between these two so that you don't confuse. Now let's discuss about Venn diagram. So Venn diagram is a representation in which we can represent some sets as a subset of universal set. So in this, the triangle is considered as a plane universal set. Okay, and the small regions are subsets of universal. So let's we can write it as that this is the universal set, and these are vowels, these are consonants, these are no, these are vowels, and the remaining area belongs to consonants. This particular whole rectangular is the universal set, which is alphabet set. Okay, so this region is representing as vowels. This is having consonants, all the consonants of English alphabet. Let's read the definition. To express the relationship among sets in a perspective way, we represent them pictorially. I don't know the pronunciation of this. Pictorially by means of diagrams known as Venn diagrams. The universal set is usually represented by a rectangular region and its subsets by circles or closed bounded regions inside the rectangular region. Let's take for some more examples. Like in this, let's say that we are discussing about numbers, and there's a set of odd numbers, a set of even numbers, and let's take the universal set as all real numbers are there. Universal set is of real number. So odd numbers set is here and even number set is here, right? Odd to represent. Let's write A for odd numbers set and B for even number set. So this is how we represent two sets on a Venn diagram where you use the universal set, which is here the case of real numbers. Okay, because A and B are the subset of real numbers. Clear? Any doubt? Any doubt? Okay, so it's almost the time. So we will discuss about Venn diagrams in tomorrow's class also, and we'll discuss the union of set and intersection of set. Okay. Any doubt from all of the class?
No doubt, sir.
Okay, so now